Good morning, good afternoon. Welcome to this webinar on security observability and how it drives application security programs. There are two presenters today. My name is Joseph Feiman. I am Chief Strategy Officer of an application security company, Avocado Systems, and my longtime colleague and friend, a managing partner of also application security company called Infrared. So let us talk about security observability and application security program. I believe it makes sense to start with a definition of security observability. It's a term that has become recently popular. Many people start using it, applying it to different disciplines within IT, to security specifically. The problem, I believe, with this term that it's not well defined. And unfortunately, I start seeing that it's been used somewhat in a vulgar sense, kind of roughly or broadly defining observability as a way to see, to view the better. And this is definitely not enough. So what if we start with an actionable definition of security observability? And the way we understand it, observability as a set of capabilities that enable you to understand your application, your API, and ecosystem. And this is done through a set of features that must be present to make observability an observability. And the first capability there is viewing application and API from the inside out. Let's stop for a second here. Traditional application security technologies before security observability, they've been typically technology that were learning security of an application or API from the outside in. They were touching application security, probing. For example, if you think of dynamic application security testing, it probes application from the outside, trying to understand potential security vulnerability. Or think of web application firewall, for example, that analyzes data stream coming to an application. But this is not a view from the inside out. What we require from security observability, you have to have some capability, a feature within the application process that would enable you to see inside of an application or your ecosystem from the inside out. Another capability is viewing application in depth. It's not enough to have some superficial look into application. You really need to see processes. First of all, imagine your application, it's an executable. You launch it and it becomes a big process that splits in multiple sub-processes. One API, another API, some database call, some call to the microservices. So you must see all this processes and sub-processes. API calls within this processes, sub-processes, and databases calls. That's what we mean by look in depth. Another capability is detecting unknown behavior. Many, if not most technology, in most cases, apply patterns and signatures to understand application behavior, to detect vulnerability. And this is a really powerful approach, but this is not enough. You need to detect anomalies and deviation. Imagine the potential attacker comes through your first layer of defenses within the application, vertically. It gets into your ecosystem and start moving horizontally. And especially with vulnerabilities such as, or attacks such as zero-day, you don't have patterns to understand malicious behavior. So what you need to have is understanding of anomalies. And if there are anomalies, you're capable to make a judgment about insecurity or potential attack or potential breach of your application. Another capability that is required is always active security. Security, or most of the security that we've been using so far for the last, I would say, decade and a half, for the last 15 years, they were traditional scanners that were scanning your application, for example, your application code, and making conclusions, making a scan DAS, dynamic application security testing, and making conclusion, doing software composition analysis and making conclusion. But after the scan is done, the next scan would be launched maybe a year from now, which is very typical for many organizations. It might be launched some weeks from now, but let's say even an hour from now, which never happens. It still means that at least for an hour, you leave your application unattended. So you cannot speak of security observability unless you have an always active security. In simpler terms, you have to have a monitor, not a scanner, or at least monitor in addition to multiple scanners. Another thing, a runtime security. Only runtime or running application at development phase when you just build the application or at operation when it's running for production can be subject of observability. It's absolutely not enough to just quote unquote view your application code, even with a somewhat powerful tool such as static application security testing. Only a runtime application characteristic becomes actionable and therefore observable. And with using this understanding, these definitions of actionable item provided by security observability, I want to speak of technologies that enable it, see what they would offer if we follow these requirements. I'm using Avocado Systems technology called Reveal in particular, that enables the security observability. But I'll be speaking in a broader term that would demonstrate what security observability would be offering us if we apply that. First of all, we already mentioned that always active security. We must endlessly, really endlessly monitor and diagnose and protect application API. If we were somewhat kind of slack in our approach some years and years before, nowadays we must be continuously watching applications running. It should be a runtime security because most of security approaches are not runtime. As we mentioned, there are scanners, but with a runtime security, we must be detecting attacks at the moment of a crime, not post factum. Happens very often. It should be really an application security posture monitored at every moment on demand. It must be producing a state of security of an application. And this security should not allow any API, actually any call, escape discovery and diagnosis. The next fundamental and mandatory things is a completeness of detail, meaning that for every endpoint, for every socket and port, it should be detecting APIs, the format, the protocol, the entire data flow that could be analyzed immediately, the origin of the call, the destination of the call. It should be detecting, and by the way, protecting as a next step, potentially, any type of API, such as REST or GraphQL or any other, and operate at sub-process level and being able to see API in its entirety. And it should be doing this within the application and outside the application. Within, I mean, it should be watching processing calls launched, for example, by your user interface, your browser, reaching out to your business logic, or from business logic, reaching out to a database that is internal. And as well, external, when your application is calling into some microservice or one microservice calling into another microservice. These three requirements, I believe, are mandatory for real security observability. A few more are somewhat important, but not mandatory. But agnosticism is very helpful when your observability is language agnostic, platform agnostic, and architecture agnostic. In the case of Avocado, it stretches from any language from Ada to Python, from monolithic application to microservice, from on-premise into the cloud, and work without any changes in all of these environments. Another desirable feature is autonomy. You should remember how difficult it is for developers, and practically impossible, to configure and tune dynamic application security testing. Absolutely impossible to configure your web application firewalls. That simply cannot be given in hands of DevOps people. So the requirements for observability to be autonomous. So you install it and it runs is very important for broadening adoption. And the last one, of course, it should be DevSecOps, meaning it should be applicable at dev as well as ops. So once application is up and running, you start observing it build after build after build until deployment, and then continue observing it at operations. So these are requirements, 3 mandatory, 3 desirable, that make observability powerful and easy to adopt. Let me show you just the difference between this on the surface look in the application offered by observability versus from inside out. This is a typical architecture that people are using to start their development process. They draw a diagram. For example, here you see whatever 6 logical blocks and about 10 or 12 arrows showing the connection. It's very unfortunate that you start with this and then you continue through the life of your application. It simply means that you never, and this unfortunate reality, you never see your real architecture, your real operational architecture, user acceptance architecture, or security architecture. This is the kind of a theoretical look from the outside in. What you really need is the look from inside out. And this is a typical example of on the left-hand side that I am showing with my cursor, with what, for example, security observability technologies such as Avocado offers. You see and this is a snapshot of a part of a much bigger application. You see every logical blocks here. Keep in mind that they are detected in real time, and you can get this diagram on demand at any moment, and you can compare it with the historical diagram that you took at the previous release and the previous release. For example, here you can see some unknown client is reaching out to application called Java 2. And that Java application is reaching out to, I believe, MySQL database. And there is a microservice calling into Java 2. And there is another calling into this Java 2 application, which finally calls into another unknown client. This is the real diagram. This is a real architecture taken on demand. But keep in mind, this is not the security architecture per se. This is not an performance architecture per se. This is the architecture. That's exactly what you've built. So that kind of observability is required. So you're not using a written diagram to imagine your application. This is not an imaginable application. This is not imaginable architecture. This is the real one. So you see all runtime logic flows. I've just shown them to you. All runtime threads flow. It's actually attack surface that we've just discovered, the calls from this unknown client into Java application and then the database. It discovered it automatically for you, all assets and processes and all dependencies. You see all application and microservices and databases. You see all API calls, so to say, and direct database calls. You see calls origins, destination. You see IPs, URLs, ports. You see data in transit. You can see the entire data stream initiated by API call. You see call dependency, and you see them inside the application and outside the application. Remember, I can show you here only a small part on this slide of much bigger application. And of course, we're showing here vulnerabilities that we detected. Here on the right-hand side, it's a standard report or actual snapshot that you can get at any time on demand. You can see that we detected remote code execution. The first vulnerability we detected, cross-site scripting, and we detected remote code execution. Here, you got the security observability that produced those results. The question comes up, what would you do what is the next step? What do you do to mitigate that? And at this moment, I'll pass screen control to my friend Eric, who would continue on that path. What would you do, Eric, with these vulnerabilities?
I love the amount of information that you're showing us, Joseph. That sort of detail about applications and what's really going on as opposed to the diagrams we like to draw is fantastic. And so For folks, my name is Eric Sheridan, managing member here at Infrared Security, and we're a company that specializes in educating your team to help produce more secure software. And so, with all the information that Joseph just talked through, there's a significant opportunity to use that to make more informed decisions about how you invest in your overall AppSec programs. And by making them more informed, they actually become more efficient. And this can include things, security testing, or designs, training, how you manage your team, where you focus that funding. And so, from my perspective, having worked in this space, for 17 plus years now, all the way from a consultant to building products and everything in between, that amount of insight is absolutely valuable. And so, from my perspective, one of the key takeaways for me is how that insight helps with respect to application security training programs. In a world of DevSecOps, DevSecOps demands efficiency. And so if you're striving for efficiency, there's no better way to do it than getting the insights out of something like a security observability technology that Joseph just walked through. So let's talk about how we can use that in the context of your application security training program and how it can make it more efficient, tailored, and tactical for your business. So right off the bat, once you start adopting a security observability technology, you're going to start getting this feed of information around vulnerabilities and risks that your applications have, right? And so you're going to start asking yourselves key questions. There's some observed risk. How do I minimize the exposure to that risk? Developers, you're going to ask yourselves, how do I remediate this vulnerability, and how do I do it quickly? I emphasize the word quickly here because if you go back to Joseph's slides, he talked about how this technology can be deployed at various stages, including pre-prod as well as production. If you get insight that there's these real vulnerabilities in your application in pre-production, you probably want to fix it before it gets to production. And if you find it in production, well, then my goodness, it's already out there. You got to get that fixed ASAP. And so this puts developers in a little bit of a dilemma. And so this is where, my experience comes in, where I think we can help. So with that said, I'm going to go ahead and share my screen here. And when I share my screen, we're going to take a look at a snippet of code that I shared over LinkedIn in preparation for this webinar. And many of you actually get to see whether or not your answer was in line with at least what I was looking for. So the code snippet you see here is a RESTful API developed in the JavaScript programming language using the Node.js runtime. Now, this piece of code is vulnerable to remote code execution, right? The type of vulnerability class that Joseph just said security observability can provide us insights into. What line do you think it's on? For those of you out there looking at this snippet of code, if you said line number 9, pat yourselves on the back. You're 100% right. So this API allows a hacker to provide a variable or in parameter called dir, D-I-R. This is then dynamically concatenated with a shell command that is then executed. If we hover our mouse over this exec function, you can see very clearly. It says spawns a shell, then executes a command. So what this means is a hacker can introduce all of those special characters a terminal or shell would accept. And in doing so, do a whole bunch of crazy things in terms of chaining commands, deleting files on your host, and maybe something even more nefarious that you could think of, right? So that's pretty bad. Your developers are going to be presented this information pretty much in real time when you have a security observability technology in place. So then the question is, okay, how do I fix this? Well, let's walk through this. And as I do this, just be mindful that there's a few traps here, right? It's like chess. There's a lot of openings. A lot of them have traps in them. If you fall for the traps, you're going to lose pieces, right? So the first thing we want to do here is change the method from exec to exec file. The exec file has a big difference in that it is similar to exec, except it does not spawn a shell. Instead, it is designed to directly invoke the program that you pass in as the first argument, right? So rather than spawning the shell or terminal or CMD, it's just going to open up the program we pass in. So let's actually pass in that program. In this case, it's going to be this program BF, right? The next thing that we need to do here, and so that's probably one of the most critical pieces right there, right? We're eliminating use of the shell and directly specifying the program we're going to execute. The next thing we need to do is delineate, using an array, the arguments we wish to pass to this program that we're executing. All right, so here I've actually delineated it. It's two of them. One is -h, and the other is the value to the -h program itself, or to the DF program itself, rather. And by delineating the arguments, you're very clearly telling Node.js, and in fact, the underlying program, that, hey, look, I'm passing in just these two arguments, treat it as just these two arguments. And so when you put all this stuff together, you have a snippet of code that can more safely execute a shell command without actually using the shell. Now, with that said, you're not necessarily out of hot water yet. You have to be mindful of things that could render such strategies moot. And here's one of them. You can pass in an option to this method, which is just like basically a JavaScript object. And there's a property called shell. And you can set it to true or false. By default, it's false. What do you think happens when you set it to true? Right. It's basically just invoking the program you're specifying through the shell, at which point, basically all the benefits I just told you about in this exec file method, you basically just threw them out the window, right? It's not going to do anything. So we definitely don't want to do that. So that's the fix of this particular code, assuming we still continue to feel like executing a third-party program was the right strategy for implementing this feature requirement. Some other folks out there on LinkedIn actually highlighted line number 14 as well as being an issue. Not necessarily the issue I was looking for, but that is a problem. Why? Well, anytime you reflect dynamic data to the response and it's not encoded, contextually encoded, you have a potential for cross-site scripting. That's actually, in fact, the second vulnerability that Joseph highlighted when he was going over the types of vulnerabilities that security observability can provide, right? So it's really useful to have that sort of information available. Now, here's the thing. There were a number of traps in there, right? There was a lot of gotchas. So if we're going to be getting this information so quickly, developers get this information so quickly, we need to make sure that they have the ability to avoid such traps on the fly, on the job. To that end, what we focus on at Infrared is a number of educational type of products, one of which is designed to help this specific case. So we developed something we call MicroLessons, which is like a catalog of 200 plus videos that span a number of vulnerability classes across a number of programming languages. And the idea is that these bite-sized videos can be integrated into the developer's daily workflow. So as they're presented with vulnerability information in real time, they get that reminder, that refresher on how to fix that vulnerability when they need it most, right? And so what's exciting for me and from the people I speak with the pressure of DevSecOps moving fast and moving efficiently, we have less time to step away into like these fictitious lab environments, working on Juice Shop, WebGoat, or some other similar type of open source vulnerability application. We need to get back to the code that we're writing, the products we're building for our business, and secure that. So by streamlining this awareness, this refresher directly with vulnerabilities as they're being presented by technologies like Avocado, it gives your developers the chance to effectively labify their own projects. So they're learning how to fix vulnerabilities in real time, which is pretty cool in my opinion. To that end, let's get a sense of what that would look like from a developer's perspective. So what I have on my screen now is a ticket tracking system called Jira. It's very popular. I'm sure if you've worked with an engineering team at some point in your career, you've probably heard of this. If you're on the security team and you're interfacing with the engineering team, you're probably capturing a lot of your guidance in the form of tickets within something like Jira. And your tickets probably look like what you see here. Right. So here's that same snippet of code that I showed you with the description effectively saying, look, it's vulnerable. It has remote code execution. Go fix it. Well, the way the strategy we take is that anytime we see a security related ticket being created within Jira, we have a technology in place that will monitor that. And when we see those tickets, we enrich it with the relevant just-in-time MicroLessons. So at the bottom here, there's a comment that was automatically appended that points the developer or developers directly to the MicroLessons designed to teach them how to fix this particular vulnerability at this point in time. All right, so if I go to the page, you can see it's preloaded. Let me go ahead and click the JavaScript remediation. You can see in 2 minutes and 22 seconds, I have everything I need to get a refresher on how to fix this vulnerability in my application, right? So that's what we talk about when it means to take sort of security education and adopt it to complement the world of DevSecOps, which is very efficiency and automation driven. This is how you get there. So let's go back to our slides now. Now that we've talked about this from the perspective of developers who are getting this real-time stream of threats and vulnerabilities, now let's step back a little bit and start to anticipate in that, how do we anticipate and minimize future risk? So if we're starting to see this information come in, how can we build a more tailored AppSec training program around this information so we can be more proactive and anticipate such threats in the future so we can respond to them more efficiently? So we have, at Infrared, like a number of security training courses. And it's a question of which ones do you choose, why, where, what teams, and so forth. And the data you get from security observability can really help answer those questions. The first one, when you are getting data from security observability, ask yourselves, what are the vulnerabilities that are being actively exploited in my applications, right? Let's get that data point. Let's focus in on what is really being exploited in your apps as opposed to, some top 10 list somewhere else that's generic for the industry, right? I don't want generic for the industry. That's not efficient. I want what is my applications are really dealing with. And that's why security observability is so critical in answering that sort of question. The next thing I want to know is what are the threats and active attacks my applications are facing? Just because the vulnerability was not there, maybe it wasn't exploited, doesn't mean I can just ignore the attacks, because the threats and the attacks that we're actively seeing give us a sense of how hackers are viewing and interacting with our software. So we want to make sure that our team is educated in those sorts of issues and how to defend against them. Third, we want to be technology focused. We saw lots of cool stuff you can get from security observability. Like, we know what architecture is being used. We know what programming languages are being used. We know what backend services are being used. Right? If you pull all that information together, what does that give you? That gives you an accurate understanding of the vulnerabilities your applications are dealing with, the threats that they're facing from the attacks, the technologies that they're using. And so for me, when I get all of that, that enables me to tailor my education down to the individual through MicroLessons, through specific teams, as well as the organization as a whole. Right? So when I'm rolling out security training courses and curricula for that particular team or teams, what vulnerabilities are they dealing with most? What sort of attacks are they facing in production the most? What technologies are they using? When you overlay all those together, it naturally filters out the courses and content and educational materials that those folks need to be more successful in defending their apps against the sort of threats that we've talked about here. So when you pull all this together, when you take the results from security observability and the insights around vulnerabilities, threats, and technologies, and how you can apply that to your individuals and teams, it actually maximizes the efficiency of your AppSec training program, providing measurable results. In terms of measurable results, you'll see things like improved time to fix or the window of exposure. So, that time for when, vulnerability is discovered to when it's actually fixed and patched in production. You'll see improvements in vulnerability discovery rate, right? How frequently are new vulnerabilities being discovered? Well, if you're actually anticipating using these three elements, vulnerabilities, threats, and technologies, you will actually be able to educate those teams so that number of those vulnerabilities in the future is less. And also helps with software delivery performance. So if you're in the security organization working with engineering teams and they're DevOps and DevSecOps oriented, they're being measured by some different statistics, right? Having security observability coupled with the sort of education that we talked about here helps with software delivery and like the Google's 4 metrics for a successful DevOps program. And so in my experience when working with customers, having this sort of insight allows them to make more efficient use of their training and increase their overall maturity from an AppSec training program perspective. So when we talk about, roughly 4 levels that we like to see our customers get to over time. When they have this sort of insight that you get from security observability, that allows me to help my customers make more informed decisions on how they structure their educational program. So, with all the information that we have here, the value of security observability to me is incredibly clear. And so it really needs to be an integral part of your workflow. And so, Joseph, passing it back to you, how do you see that being integral within an organization?
Yeah, thank you, Eric. Couple things, really, 2. One, you mentioned that this runtime, just-in-time education should be integrated into CICD cycle, and you actually demonstrated how we can do it through integration into Jira. The questions come up: will observability follow it? Can observability be integrated into lifecycle? And I want to answer yes, it is doable. And second, I want to show you how it could be done. For example, here's the CI/CD cycle. In development, you program your application, you create it, you written your code, then you do quality assurance analysis of the code, and then ideally you would do static application security testing. You would test your code, analyze your code before building and deployment. You test for security vulnerability. Then you start building your application out of multiple units of the code created by you and some other team members. At that moment, for example, in our case of Avocado, you can include into build Avocado plugin and orchestrator, 2 pieces of Avocado, the control board and the agent, plugin that will be watching for API calls with their installers. So they'll become a part of the package. And when you deploy your application, they will be executed and they'll start running in containers in the Kubernetes cluster, for example. And at that time, it's a build time now, and you are running your application and testing it. You are applying functional testing. You're doing user acceptance testing and performance testing, and you do dynamic application security testing and maybe penetration testing run by human experts in security vulnerabilities. And whatever you do, all these efforts, quality assurance or security assurance, they are observed by Avocado. So it gives you that diagram that I've shown you. It gives you a complete architecture at any moment on demand, so you can see all connections, all calls to databases, to microservices at any moment. As well, you can see security vulnerabilities, of which Eric mentioned how you can mitigate that. And then in operation, you can continue it, but this time it will not be vulnerability per se. It will be potentially exploited vulnerability because you'll see real attacks, not a test. So my first point was to say is that, like Eric said, that just-in-time training could be integrated into CI/CD. Observability itself that gives you food for thoughts could be integrated into CI/CD as well. And remember, we mentioned that it's autonomous. Once you install it, you don't need to tune it up. You don't need to configure it. And the last thing that I want to mention, use cases for observability, where you would apply this or that observability. And number one, it's an architectural model. You can see your real architecture under quality assurance test, as we said, and the security test, You can see all assets, all flows, dependencies. So all this, finally, you're having not a diagram, the handwritten diagram, your imaginable architecture that you think you're building and running. You see the real architecture. So that makes DevSecOps faster and cheaper, because at any moment, any dev or ops person can dev this architecture and see whether it's the architecture that he or she wants to build and run. Second, of course, is very important for a security specialist: vulnerability detection and threat modeling and security testing. You saw these vulnerabilities on the right-hand side of the model. They come with every snapshot, and it is security posture of an application that you continuously monitor. So these two are great and yet typical. The third one came up maybe somewhat as a surprise to me and to us in the company. The third use case, it's actually cloud and legacy migration. Imagine you have an application written in some legacy programming language. Think of Department of Defense, ADA language. I believe it's 30 plus years old. And these days, you want to migrate this application from legacy to modern architecture, from monolithic to microservices, and maybe even from on-prem into the cloud. But you don't have developers. They left a long time ago. In many cases, you simply lost your source code. You only have an executable. How would you migrate it, keeping its important functionality? Well, security observability, like one I've just shown you, gives you a perfect tool to do this. You run your application, you see exactly what it is, all calls to databases, to other services, to other routines. So now you can start reprogramming parts of your application, let's say in modern languages, maybe in Python, for example, or using Node.js. And at every step, you can see how the logic is changing, the architecture is changing, and you can see whether you're getting what you actually plan to get. Is that the architecture that you are actually building? So at the end of this migration process, you can see whether the final architecture meets the requirements and does functionality that you expected from the old legacy application plus new functionality capabilities. And now you can safely see that you're migrating from legacy to modern, from monolithic to microservices, migrating it from on-premise into cloud. That's interesting enough. It's something unexpected, but become captured immediately by the clients that realize that it's a very important tool, that security observability, that can help with their migration. And the last thing scenario is compliance and protection. With security observability, you can enforce compliance, and in some cases, if you wish, even protection, because steps for protection, such as dropping an API if you want to do it, or for example, for a legacy application whose data stream, data in transit, data is not encrypted, you can encrypt it in real time as protection efforts. You can do it here as well. So these are my few use cases, some expected, some somewhat unexpected, where security observability plays a critical role. We're coming to the end of our presentation. Any questions, Eric? Any comments? Any additional thoughts on that regard?
Yeah, we do have a few questions. Before I kind of review what I saw from a question perspective, that the cloud migration piece I thought was kind of interesting. And so, like, for those of you out there on the security teams that are working with engineering teams, anytime you can provide security benefit to the team, but also an engineering benefit, makes it much more easy to adopt from an engineering perspective. Because, hey, if I use this tool, not only do I get security benefit, but I can ease my cloud migration. Yeah. So there's less resistance with stuff like that. So it's really cool that you all pointed that out, Joseph.
Eric, you have access to chat, so could you read the questions?
You bet.
And we'll see who would answer them.
The first one says, and Joseph, this is for you. We use a lot of different programming technologies. How would security observability work in such a disparate environment?
I believe we mentioned at the very beginning that one of the not mandatory but highly desired requirements is agnosticism of security observability technology. So it would be agnostic to the programming language. And in our example, in the example of Avocado, it can work with application written in Ada 40 years ago, as well as do observability in the application written in Python just 40 days ago. It can work with monolithic applications, and it can work with microservices. So it is all presentable. The modern observability ideally would have to be in runtime, to being insightful, to be inside out. It should be agnostic. So it would be for real good technology for security observability is not an issue. If it's agnostic, no issue to your existing different programming languages or existing architectures.
Very cool. The next one was, what other vulnerabilities do you cover with the MicroLessons? So I'll take that one. Several. The one I demoed, when I took you to the page, it showed, what was it? OS command injection, remote code execution vulnerability, because that was, pertinent to the demonstration itself. But there's a number of others that are covered, like cross-site request forgery, SQL injection, cross-site scripting, brute force, all the big ones. And so obviously you need to cover a lot to be able to support today's applications. The next one we had was, this one says, Joseph, I think this is for you. You effectively says you missed threat modeling as an integral part. Does security observability help with that?
Well, it's a really good question, and thank you for the person asking it. Really, when we start thinking of application security, we start thinking with the programming phase. When you just program the code, and then you have technologies such as SAST to test the code, and then you have an operational technology, and you use DAST, and somewhere you use software composition analysis. Realistically, yes, you should start with the architecture model and threat model and do threat modeling. Yes, observability has a perfect case, and I have a webinar, if you search somewhere in August, on the threat modeling and observability. See, the problem with a traditional threat modeling, practically all 100% of all tools start with requirements. Draw your diagram. And they help you to draw the diagram. And this is the beginning of incorrect, of error-prone, security box-prone method of building an application. Very soon, you can start, and you should start, there is no problem other way, but to start with a diagram. But the moment any piece of code, any unit of the code, I have to say, is capable of running, you should apply observability and get the diagram, and you would immediately see not imaginable architecture that you've just drawn on your diagram, but you would see the real architecture. And that would give you an immediate gap, and you would see really what you need to change. So you're making changes, and you run this observability to like hours, and you see the next phase, the version 2, and you can see how your application architecture and threat architecture really change. And you go to the next step and the next step. And down the road, you're applying this learning technologies that Eric mentioned, and you learn how to fix, and you fix vulnerability, and you move from step to step. This is the real way of applying observability into building an architecture that you really should have, not one that you imagine. So there is a perfect fit for security observability into threat modeling. And by the way, you can do it on your own within your tool, or you can push this the architecture, for example, the one of shown by Avocado, into JSON file and get it integrated with a traditional or more popular threat modeling tools such as WASP, ThreatDragon, or TMT. And there you can start playing what if game. So it is all available. There was a great match between threat modeling and security observability.
Cool. I think from a time perspective, that's it for questions. Joseph, thank you so much for having me on. It was great to present with you as always. So just fun.
It was a pleasure. Nice to see you. Thank you, everyone, for attending it. And it will be posted on YouTube as well as on Brighton. Good day. Goodbye.
Bye.